Hi, my name is Isabel Molina, and I will be presenting collisions in physics. So there are two types of collisions, elastic and inelastic. Inelastic collisions can be complete or partial. And so first of all, for elastic collisions in the one dimension, we have two particles of mass m1 and mass m2. We have to use the law of conservation of kinetic energy for elastic collisions and also the law of conservation of linear momentum because both are conserved in elastic collisions, as you can see in the images above. So in an inelastic collision, kinetic energy is not conserved, and this is because the velocities change. So kinetic energy is transferred either to both particles or it is cancelled out. So there are two types of inelastic collisions. In one, two objects stick together and they move in the same direction, and this is a perfectly inelastic collision. And in the other, the objects will collide head-on and stay in place because the momentums cross out, meaning that they will not be in motion. This means that they have no velocity. Now, to conduct a collisions experiment, you will need two carts, a cart track with stands, a camera and motion detectors or readers, and a computer to help you analyze data. Now, for the procedure of an elastic collision, you will place two motion detectors at the end of the track, one on each side. You will place one cart in the middle of the track and another cart at one end of the track. Turn on the motion sensors to the cart setting. You will have the computer ready to read data about the cart's velocities. It will show up on a velocity versus time graph. Now, careful as to not disturb the readings, push the cart at the end of the track towards the one in the middle. What will happen is that the cart will transfer kinetic energy to the second cart, making the first cart not move. So, analyzing your data, you will see that there is a conservation of kinetic energy if your collision was elastic. Now, doing an inelastic collision, we will first be doing the perfectly inelastic. So you're going to have the same setup. You'll have two motion detectors at the end of the track, one on each side, and you will place one cart in the middle of the track and another one at the end of the track. Be sure that the Velcro strips on the carts are facing each other so that when they collide, they will stick. Turn on the motion detector to the cart setting and have your computer ready to read the data about the cart's velocity in a velocity versus time graph. Now, careful as to not disturb the readings, push the cart at the end of the track towards the one in the middle. And what will happen is that they will stick together and they will move in the same direction. If your collision was perfectly inelastic, there will be a difference in velocity because there was a change in momentum and kinetic energy. This is what it will look like. Now, for the second inelastic collision, you will place two motion sensors at the end of the track, one on each side. Place one cart at the end of each side of the track. Turn on your motion sensor to cart setting and have your computer ready to read data about the cart's velocities in a velocity versus time graph. Now, careful as to not disturb the readings, push both carts simultaneously towards the middle of the track with the Velcro sides facing each other so that they will stick upon collision. What will happen is that both carts, if you push them at the same time, they will collide in the middle, but because they have the same mass and the same velocity, they will cross out and they will not move in either direction. This means that that you had an inelastic collision because there's a difference in velocity, and so there's a change in kinetic energy and your momentum was crossed out. So this is approximately what it will look like. So this is what your graph should look like if you have an elastic collision, and this is what it will look like if you have an inelastic collision. Thank you for watching.